What's up, Algebra 1 students? This is lesson 38. Our objective is how do you simplify expressions using the greatest common factor, or GCF. Before we get into that real in-depth, let's just remember how to find prime factorization of numbers. So there's a couple different ways that the book shows. Let's just see what we can do here. So remember, probably the easiest way for me to find prime factorization is just to do a factor tree. So let's just think of two numbers that multiply together to give me 180. So first thing I think of is 18 and 10. And now let's just break each of those up. 18, I think of 2 times 9. 2 is a prime number. 9 is 3 times 3, and 3 is prime numbers. 10 is 2 times 5, and those are both prime numbers. So the prime factorization just means write this all out. So 180 is what written as a product of prime numbers. So this is going to be 2 times 2 times 3 times 3 times 5. And if you said 2 times 2 times 3 times 3 times 5, you get 180. This is how your book writes it out. Another way that a lot of people write that is to say 2 squared times 3 squared times 5. So either one of those would be just fine. Alright, now let's do this next one. Seems to be a little bit more complicated here. I'm going to say 10 times 273. 10 is again 2 times 5. Those are both prime numbers. That one's not even. Alright, 273. So maybe let's try 3. 273 divided by 3. Yes, that's 3 and 91. 3's prime. But what about 91? Alright, so 2 doesn't go into that. 3, does 91 divided by 3 work? Nope. 91 divided by 4 wouldn't work because 2 doesn't go into it. 5 won't. 6 won't because 2 and 3 won't. What about 7? 91 divided by 7. And yes, that's what it is. 7 and 13. And remember that those are both prime numbers as well. So this one is going to have 2 times 3 times 5 times 7 times 13. Alright, and here this part C, I guess we could call it, is to find their greatest common factor. Okay, now let's just break down what does it mean to be a greatest common factor. Greatest, I think, is a fairly easy word to figure out, the biggest one. Common, something that they both have. So the main thing we're trying to figure out is what does factor mean? Well, factor is just numbers that multiply together to give you that number. So the factors of 180 are 2, 2, 3, 3, and 5. Those all would multiply together. So each of those in there are a factor. So we're wanting the greatest common factor. So what we're looking for is prime factors in both of these that they both have. So I see that they both have a 2. They both have a 3. They both have a 5. And there's no other numbers in common. Now, if there was another 2 or something, we would want to circle all of them. So the greatest common factor here is going to be 2 times 3 times 5, which is going to be, 6 times 5, which is going to be 30. So the greatest common factor of these two numbers, the greatest number that's a factor of each of those numbers is 30. Alright, so we're doing the same thing now, except for with letters mixed in there with it. So don't freak out, don't run from the room. You got this, we can do this. Here we go. So let's just look at each term individually. This one, and then this one next. So 9 is 3 times 3. A to the 4th means A times A times A times A. B to the 7th means B times B. 4, 5, 6, 7. Alright, 12 is 2 times 2 times 3. You could have figured that out, I'm sure. Times A times A times B times B. So the greatest common factor of these is we're just looking for what do they have in common. So let's just circle the ones they have in common here. They both have a 3. They both have 2 A's. And they both have 2 B's. So the greatest common factor there is going to be 3 times A times A times B times B. Of course, we can simplify that down, so this is going to be 3A squared B squared. It's the greatest common factor of those. Okay. Now, the next thing is going to ask us to factor, which we're going to use our greatest common factor in order to do that. But let's first remember how to use a distributive property. If you get something like this and it asks you to distribute, you take this 2x and multiply by each one of these inside. This times this, this times this, this times this. That's how we get these things. 2x times x squared, that's this first one. 2x times y, that's the second one. And then 2x times 1 is this last one. Okay? And then let's just simplify down to get this last answer. So notice this one and this one are exactly the same. Those are equal. They're just a different way of writing it. So we're going to do something similar right here. But in order to do that, first we need to find the greatest common factor of all three of those. So let's write out each of those. The first one here, I guess I'll write in green. This is going to be 3 times 3 times x times x times x times x. So that one's in green. Minus 3 times x times x. And then this last one is going to be plus x. So looking for ones that they all three have in common. So they all have simply just an x in common. So, since they all have an x in common, I'm going to take that piece out. I'm going to write it on the outside of my parentheses. And on the inside of my parentheses, I'm going to write what's left. So I'm looking right here. I've taken out this x right here. So I have 3 times 3 times x times x times x left over. Well, 3 times 3 is 9. X times x is x cubed. So I'm going to write it like that. 9x cubed. Keep that same sign, negative. What's left over from the second term, the red one? Well, just a 3 and an x. And then plus, and this is where it gets tricky. It kind of feels like I took out the x, right? And we did, but we have to have something here in order, because remember we started out with 1, 2, 3 terms. If I don't have 1, 2, 3 terms here, it's not going to distribute back in. Well, if you notice back over here on the right what we did, see how just this 2x was on the outside? Notice there was a 1 there to hold its place value. So that's what we're going to do here, is put a 1 right there to hold its place value. So factoring it out, my answer is going to be x times 9x cubed minus 3x plus 1. And if you were to distribute this x times each of these back in, then you end up exactly back with this original expression here. Alright, now this is like example 4, and I need you to be really careful with this because a lot of people make mistakes on this. Let's just real quick before we do these review right up here. 2 plus 8 divided by 2. We know that is 10 divided by 2, which is 5. What some people try to do is they're like, oh, I can cancel these out. Whew, that's just 8. Okay? But we cannot do that. That is not true. Shh. However, what is true is if they're multiplying. Notice here these were adding, so we cannot do that. But when they're multiplying, notice this one is multiplying. When we have factors, we can do that because it does work out. 2 times 8 is 16, and 16 divided by 2 is 8. So we could actually just reduce those, right? That's 1 times 8, and this would just give me 8. So we can do it when they're multiplying, not when they're adding. So what we need to do is we need to factor that numerator, kind of like we did in the previous example, factor the top, and then reduce with my denominator with the bottom. So what does the top have in common? This 4x and the 8. If we want to write that out, this would be 2 times 2 times x plus 2 times 2 times 2. Notice that they both have 2 2's. So I could rewrite this as 2 times 2, or just 4 times what's left over, x plus 2 over 4. So notice real quick, this 2 and 2 came right here, and that 2 and 2 came right here. The leftover x is there, leftover 2 is there. And if you were to multiply this back in, 4 times x is 4x, 4 times 2 is 8. So this is the same thing as that. But now that these two are multiplying, I can reduce just like I did right up here. These two will reduce to 1, and my answer is just going to leave me with an x plus 2. Let's simplify it down. Doing something similar over here. It's going to be 2 times 3 times a minus 2 times 2 times 3 times 3 times a times a. So I'm noticing that they both have a 2, 3, and an a. 2, a 3, and an a. So 2 times 3 is 6, so I'm going to have 6a on the outside. Left over, I'm going to have a 1 because I took everything from this first one, so I'll have a 1 there. Minus what's left over, 2 times 3 is 6, so 6a. All over 6ab. So again, this numerator and this numerator are the same, they're just written differently. If I took that 6a times 1, give me 6a, 6a times 6a, give me that 36a squared. My denominator is the same. Now that these are multiplying, I can just reduce. So those 6's will reduce to 1, and those a's will reduce to 1, but notice I still have that b left over down there on the bottom. So then my answer is going to be 1 minus 6a, that's what's left over on the top, over b, which is what's left over on the bottom. Your homework is on page 240. You're going to do all 38s, 37s, and then 9 more of your choice. Good luck.